Hello everyone, welcome to my class. In our earlier classes, we have discussed some concepts on force, isn't it? So today we are going to discuss another important concept on force, that is equilibrium of body. Okay, so without wasting any time, let us start the class. Students, whenever multiple forces are applied on a body, then it might happen that the state of the body might not change. That means it might not change the linear motion of the body. Or whenever the algebraic sum of the moment of forces acting upon a body is zero, then what happens? The body might not rotate. That means it will not go through the rotational motion. So this is called the state of equilibrium. So we can say that if multiple forces acting upon a body do not produce any change in the state of rest or that of linear motion or that of rotational motion of the body, then we can say that the body is in equilibrium. Okay, so let us now discuss about types of equilibrium. Students, equilibrium of a body is of two types. One is static equilibrium and other is dynamic equilibrium. Okay, so now we are going to discuss about static equilibrium. So what do you mean by static? It means at rest. Okay, so if several forces are acting upon a body, still the body remains at its state of rest, then we can say that the body is following the static equilibrium or it is in static equilibrium. So let us take an example. Okay, a book is placed on a table. Suppose this is the surface of the table and let us have a book on it. Okay. Fine. Suppose this is a book lying on a table. Okay. So what happens over here? If we apply force towards right and towards left side of the book. Suppose I apply force over here. And it should be in a single line. The line of force should be same. Okay. The line of force should be same. Suppose this is the force F towards right and same magnitude of force F dash is applied towards left and in the same line. So what happens over here? Because the magnitude of force is equal and both the forces are acting in exactly opposite direction in a single line, the book remains at the same position. That means it remains at its state of rest. So this is called your static equilibrium. Okay, and we can take some other examples as well. See, whenever a book is placed on the table, what happens? The book applies a force on the surface of the table in the downward direction vertically. In the same way, the surface of the table, it applies a force on the book that is vertically in the upward direction. So in this case also, the book remains at its state of rest. That means it follows the static equilibrium. See, you might have seen a beam balance. You might have gone to the market to purchase some vegetable or some other things, isn't it? And what you have seen that the shopkeeper keeps the beam balance in one hand and keeps it in an upward direction, and it first of all shows us that both the pans are at the same height or they are at the same level. Then the shopkeeper puts some weights on one pan and it puts same amount of products at the other pan and again it balances it till the time both the pans are at the same level. So in that case, what is happening actually, on one pan we are having some products and it balances the moment of force because of the weights that we put on the other pan. So it is not actually following the rotational motion. In that case, it is at rest. Both the pans are at rest. You might have seen that sometimes the shopkeeper tries to put some extra amount of product on the pan or it takes out some product. Why? Because he tries to give us the exact amount or exact quantity of product. And in that state, as the beam balance doesn't have the rotational motion, we say that that is in static equilibrium. Okay? Hope you understand. Students, let us now discuss about dynamic equilibrium. Okay? See, whenever a body remains in its state of motion, that means whatever the motion it is following, it remains in that motion. Let it be translation motion or rotational motion. Then we say that it is in its dynamic equilibrium. Students, whenever rain falls, what happens? The raindrops, they fall with a certain weight. Okay, but they follow a constant velocity. Why? Because the weight of the raindrop, that is balanced by the total buoyant force acting upon them and the viscosity, that means the friction in air. Okay, so those balances the weight of the raindrop. That is why it follows a constant velocity. Whenever an aeroplane flies at a certain height, what happens? It has got some weight, okay, but that weight is balanced by the uplift that is acting upon the aeroplane. It helps the aeroplane to fly at a constant height. Okay, same way, whenever a stone is attached to a string and it is being rotated, it follows a uniform speed. Why? Because the tension that acts on the string, it applies a centripetal force, and because of the centripetal force, it can maintain a uniform speed. Okay, we can have lot many examples like that. In such cases, as we have already discussed, that a body that is in translation motion, it remains in its translation motion, or a body which is following a rotational motion, it follows the rotational motion. Okay, that is why these bodies are called to be in dynamic equilibrium. Okay, students, let us now discuss about the conditions for equilibrium. Okay, the resultant of all the forces acting on the body should be 0, and the algebraic sum of moments of force of all forces acting on the body about the point of rotation should be 0. These are the two conditions that are to be satisfied for a body to be in equilibrium. Okay? Students, whenever multiple forces act upon a pivoted body, what happens? The body tends to rotate about its axis of rotation, isn't it? So, in that case, the resultant moment of force is taken as the algebraic sum of all the forces acting upon the body. So, in that case, the anti-clockwise forces, they are taken as positive, and clockwise forces, they are taken as negative. Fine. So, whenever a body is at equilibrium, it doesn't rotate about its axis of rotation. We have already discussed about that. So, what should be the values of these two forces? They should be equal, isn't it? If they are equal, then the total resultant force would be 0, isn't it? So, if the resultant force is 0, the body will follow the state of equilibrium. So, as per the principle of moments, for a body to be in equilibrium, the sum of anti-clockwise moments of force should be equal to the sum of clockwise moments of force. Okay, so when they are equal, the resultant force will be, one is positive, one is negative. This is positive and this is negative. So if they are equal, the sum is equal to 0. For example, plus 5 minus 5 gives us 0, isn't it? So if they are equal, then their algebraic sum should give us 0. That means it is in equilibrium. Okay, hope you understand. Students, let us now try to verify the principle of moments with the help of an activity. Okay, as you can see in this diagram, that there is a support to which a string is attached and a ruler is attached to the string. Okay, the string is attached to the center O of the ruler, and there are two spring balances A and B attached to two different points of the ruler having two different weights W1 and W2. Now in this case, what might happen, that the weights, they might try to tilt the ruler in one side. Why? Because W1 will try to tilt the ruler in this direction and W2 will try to tilt the ruler in this direction. W1 will try to tilt the ruler in clockwise direction, W2 will try to tilt the ruler in the anti-clockwise direction. So how we can bring the ruler into equilibrium? That means it should be horizontal. Okay, we can try to change the value of W1 or W2, or we can shift the spring balances on either side of the center of the ruler so that the ruler comes to equilibrium. That means it should be at a horizontal position. As you can see in this diagram, spring balance A is at a distance of L1 and spring balance B is at a distance of L2 from the center. Here you can clearly observe that L1 is greater than L2, but the ruler is still at its horizontal position and it is in equilibrium. It is at rest. Okay, it is not going through any rotational motion. So in that case, what would be the moment of force at A? At A, moment of force would be W1 into L1, and at B it should be W2 L2. Okay, product of weight and perpendicular distance, product of weight and perpendicular distance, as we have already discussed. So in this case, what is happening that W1 L1 is equal to W2 L2. So over here, anti-clockwise moment is equal to the clockwise moment. This verifies the principle of moments. Okay, hope you understand. Students, let us now discuss an example to understand the principle of moments in a better way. Okay, suppose we have a seesaw and two children of mass, suppose 30 kg and 50 kg. They are seated at one side of the seesaw at two different lengths, 2 meter and 2.5 meter. So what should be their weight then? W1 will be 30 kgf and W2 would be 50 kgf. Fine. So the moment of force at two different points. A child is seated at A, another is at B. So at A the moment of force would be 30 kgf into 2 meter, and that at B would be 50 kgf into 2.5 meter. Okay, so what would be the total moment of force at this side, at the left side of the seesaw? That would be 60 kgf meter plus 125 kgf meter. Fine. So that is equal to 185 kgf meter. And if we are asked to place a person of mass 75 kg at the right side of the seesaw, then what is the distance from the center that he should be seated at? Okay, so that means the weight would be 75 kgf. Okay, so now we know that to be in equilibrium, L1 W1 would be equal to L2 W2. That implies length is equal to L1 W1 by W2. L1 W1 is found to be 185 kgf meter. So that would be equal to 185 kgf meter divided by W2 is your 75 kgf. So when we cancel out and calculate, it would come about 2.47 meter. Okay, so this is the distance from center at which the person having weight of 75 kgf to be seated on. Then what will happen that the seesaw will come into its equilibrium state. That means it will be horizontal with the ground. Okay, hope you understand. Students, today we have discussed about equilibrium of the bodies and the principle of moments. Hope you have understood everything clearly. If not, please watch the video again, read the book, and I hope you would understand everything clearly. Please revise again and again to keep the concepts in your mind forever. Okay? So as I always say, keep revising, keep practicing, and most importantly, keep smiling.